HVAC temp rise formula for measuring airflow. CFM gives a fast, accurate check on system performance and pinpoints airflow problems before they damage equipment. Use the temperature rise formula CFM equals sensible heat load divided by the product of 1.08 and DeltaT to measure airflow without instruments tied to pitot readings. First, calculate sensible heat load from the rated output in British thermal units per hour. Then divide by 1.08 times the measured temperature rise to get cubic feet per minute, and always convert furnace nameplate output to net heat by subtracting blower heat if specified by the manufacturer. When DeltaT is much higher than the manufacturer range, methodically confirm the blower motor and wheel condition. Measure motor amperage against nameplate and check wheel for ice, dirt, or bowed blades that reduce volume. Inspect supply and return filters, registers, and duct runs for restrictions. Run a quick static pressure check across the air handler if you can to quantify losses and compare to the system design static. Aim for total external static below the equipment recommended maximum. Verify thermostat and sensor location so the sensor is not in direct sun, near the register, or influenced by return plenum radiant sources. 3 inches away from metal flanges and 6 inches from registers is a good rule of thumb for placement. Check for proper fan speed selection or control board tap settings on fixed speed motors, and verify variable speed drive signals for variable air volume systems. Incorrect fan curves will skew the CFM calculation. For equipment level issues, confirm heat exchanger integrity and combustion safety first to rule out overheating caused by blocked heat transfer rather than airflow. A sealed heat exchanger with restricted airflow will show high DeltaT but different safety codes implications. Use a simple balancing move. Close oversupplied register slightly and remeasure DeltaT and room temperatures to see if localized drops reveal distribution issues versus central airflow loss. Keep a notebook with serial numbers, measured DeltaT at full fire and idle, static pressures, and amperage so trends reveal a slowly failing blower or progressive duct collapse before sudden failure. One of the most common mistakes is incorrect sensor placement causing false high DeltaT readings. .C. Fix by relocating the sensor away from radiant heat, registers, and direct sunlight and recheck after a 10 to 15 minute steady state run. One of the biggest issues is clogged or undersized return ducts, creating low return CFM and high temperature rise (EZAS). Remedy by cleaning filters, enlarging or adding returns, and measuring static pressure to verify improvements. One of the frequent installation errors is wrong fan curve or motor tap selection producing insufficient airflow despite apparent normal motor operation (UI). Correct by matching fan curve to system design, checking motor wiring taps, or installing a properly sized variable speed drive, and then recalculating CFM with the temp rise formula. BigHomeProjects.com lists vetted HVAC contractors and provides local reviews so homeowners can find technicians who correctly diagnose temperature rise and airflow. The directory helps contractors get local leads by showcasing verified work and building trust with homeowners searching for reliable HVAC service.